Good evening, my name is Aryan Mukit, and today I will show the video of part 2 of the Lab 3 project. And for the part 2, we are making a video for 2D flow over a cylinder, which is a circle diameter in 2D. And for this video, we are gonna only use the Inviscid flow, and the frequency will make 60 Hertz. Let's get started. First, we'll open our NSYS and we will choose Fluid Flow Fluent. And we click the geometry and make sure our analysis type is 2D. All the things we're doing here, it's 2D. We are not dealing with 3D here. That's why I should make sure the analysis type is 2D. Then we'll go to geometry and right click to the geometry to open design modeler. Once design modeler is open, we'll go to file to import an external geometry. This is the wind tunnel we made on our lab 2. So we'll go our experiment to choose our wind tunnel. This is made in SolidWorks, so make sure that you're choosing .igs file. Import one, we'll generate it here. And now we will import our another geometry, which is a 2D cylinder, which is a circle. So we will import it here. You can see this is our wind tunnel and this is our cylinder. Now we will go to create and boolean. And in the boolean operation, we will choose subtract. For the targeted body, we'll choose everything, apply, and for the two bodies, we'll choose the circle, our 2D cylinder, and choose the second plane and apply. Now we'll go back to boolean again, and we will generate. Once you generate this geometry looks good. This is our cylinder, 2D cylinder, and this is our wind tunnel. We can close these things up. Then we'll go to our mesh, we'll right click to our mesh, and we will edit it. Right, once it open, it will take some time to load everything from your geometry section. There we go. The first thing we're gonna do, we're gonna naming the edge, and this is the safety inlet. This is outlet. These are on the walls. We have to make sure that we are selecting every single one, and we are naming walls. Now we are gonna choose the cylinder. So if you go to the name selection, first you could see this is our velocity inlet, this is our velocity outlet, this is the on walls, and this is the circle. All right, now go to actual meshing, you'll choose mesh, you'll go to method, you'll choose the geometry, choose the whole wind tunnel, and I'm gonna apply, and go to the method, and then drop down, you'll choose triangle. Go to mesh, and element size. For the sake of this video, I'm going to use 0.05. Go back to mesh again and generate. It takes some time to generate. Yep, here we go. We got a nice and fine mesh. This is our 2D circle cylinder, and this is our wind tunnel. Perfect. When it's done, we can close these things up and right click update. Make sure you're updating your mesh. It could take some time. Okay, once it's done, we'll go to setup, right click and edit. And make sure it's a double precision and to solver process. Start. Right, here you go. You can see that's your wind tunnel. That is the velocity inlet, and on the right side is your outlet. And this is your circle, which is a 2D cylinder. Okay, now we will go to our model and we will choose the energy equation. We'll choose our energy equation and OK. Then we'll go to the viscous. Since we are using the Inviscid flow, we will choose Inviscid and OK. All right, then we'll go to our boundary condition, inlet and velocity inlet. Since we are using the 60 hertz only for this video, for the velocity for the 60 hertz, we calculated it 4.709477. Apply and close. Right. Now we go to our reference value. From the compute from, we will choose velocity inlet. If you choose the velocity inlet and everything is correct, you could see your velocity inlet number in here automatically populated. Then you will go to reference zone and you will choose surface body. All right, then next we will do the initialization. It's hybrid initialization and we'll choose initialize. You'll see there's a warning that the convergent tolerance of something is not reached, but that's fine for now. We'll go to our run calculation. For the sake of this video, I'm going to use 200 and calculate. It could take some time to actually calculate and give you the results. You can see the calculations are complete. Okay, you could come here on the results section and you will go to the plot. Since for this part 2, we want two things. We want the positions versus the velocity uh, plot, and we want the pressure position versus the pressure coefficient plot. It's all surface over the cylinder. So the first one will choose the velocity, x-axis will choose the direction vector, and the surface will choose circle. We'll save the plot, and we could see this is our plot for positions versus the velocity. Now to save this data, we can just click right to file here, and we can click this button on the left side, right? This is actually going to save as a text file to all the data from this ANSYS file that we can use it for the next for our Excel to create actual plot. Then we can go to the pressure and we can choose the static pressure There's a drop down menu. You can choose static, you can choose dynamic, and you can choose a pressure coefficient as well. We can choose a static pressure, and we can see this is our static pressure position versus static pressure graph. And also, uh, since we want the pressure coefficient, we can uh, uh, choose the dynamic pressure as well. And you can see this is our dynamic pressure graph. And since we need the free stream pressure to actually calculate the static, and also if you want to save this file, just click the right to file and right click here. It will automatically save to your computer. I'm not going to save it. I already have those files. So now I'm going to show you how you could get your free stream pressure by using a probe. For that, you have to go back to the workbench again, and for the results, double click to the results. Right, it's here. We'll create a contour. Some pressure tool. And for the location, I'm going to choose symmetry 1. And for the contour, choose 110. Click apply. You can see it looks good. Now we have to use the probe to actually get the free stream pressure. For the probe, you can see there is like a pen on the top, which it says the probe. You choose the probe, and you want to make sure that you are placing it in the middle of the test section without any color change. The color change means there is a velocity effect or the pressure effect. We don't want any effect to have on your probe, so you're gonna place it somewhere here, and you can see on the down you could see the pressure. It's negative 60.4652. That's actually a free stream pressure number. You can use this and the static and dynamic pressure to actually calculate all your pressure coefficient. I already calculated everything from the ANSYS graph, and that is my graph I got from the position versus velocity for Inviscid flow, 30 and 60 hertz, position versus pressure coefficient for Inviscid 30 and 60 hertz, position versus velocity 30 and 60 hertz. This is for the viscous flow, and position versus pressure coefficient for the viscous flow 30 and 60 hertz. That's how you could create your ANSYS, and you can get your ANSYS data to actually use it on the Excel to plot. Thank you.